All right, we have two speakers this evening. The second speaker, who will come later, was formerly with Juniper Networks and Citrix. He's also the co-founder and CTO of Heimdall Data, Erik Brandsberg. Thank you. And now we have the other co-founder of Heimdall Data. Please welcome Roland Lee.
Good evening, everyone. Thank you all for coming. My name is Roland Lee. I'm the VP of Products at Heimdall Data. Just a little bit about me. I flew in early today from California. I'm a Bay Area native in the Silicon Valley. And my background is in internet data optimization. So my focus has been like building routers, switches, load balancers, and really optimizing HTTP traffic. How do we make the internet faster? And that's how I met Erik many years ago, over a decade ago. And we did some research, and we said, you know, we've been optimizing the front end, HTTP traffic, but really the last frontier is really optimizing the backend data infrastructure. As the internet traffic's growing, a lot of optimization like caching via CDNs and client-side caching. It's been there, done that. The last frontier is really the back end, where mobile traffic's growing, and you need a lot of applications that are wanting curated data. It's going to the back-end database, and the database is getting overwhelmed. And that's really the innovation, Erik's innovation of Heimdall Data. We optimize all data at the back end, and that's what we're going to share with you today. And I think you're going to find it very interesting because it's not something that you probably have ever heard of before. And it's very simple, and the agenda is going to be as follows. We're going to give an introduction. I'm going to show you probably about 5 slides, 7 slides, and we're going to go. And then the second part, we're going to go straight into a demo, a technical demo for which Erik will be presenting. And this will be an open discussion. If you have any questions, if we're not very clear, we're happy to clarify it. And again, this is not so much a product pitch, but just sharing an idea of the concept of a database proxy and something that you may want to consider, whether a developer or a DBA. So with that, maybe I can have a show of hands. How many of you are back-end developers? Can I show of hands? Okay. How many of you are DBAs? Oh, okay. So you're mostly developers. Great. Okay. So I hope you will enjoy this presentation. So why don't we get started? So let's talk about web challenges. Obviously, as developers, as your traffic grows, more users, more applications imply higher data volume, which implies more tables and more changes to schema. And then lastly, I put in bold, is that also implies higher network latency. And this is the piece where I believe people neglect and don't understand the implications of why your application performance is slower. Oftentimes, people deploy applications in AWS or Azure, and they say, oh, reliability, performance, they got that all taken care of. I just pay a per hour price, and they take care of all. I just need to make sure the feature functionality is there. Not so. Because as more and more applications are being deployed in the, let's say AWS, for example, the application database becomes geographically dispersed. Does that make sense? When you instantiate a new database instance, that could be, even though your databases could be in California, it could be hypothetically in New York. It could be in China. It's based on the configuration, the availability zone, and also the resource that's available. And that distance between the application and database, that latency, that round trip time, can really slow down your application. And that's one of the things we're trying to solve. Does that make sense? So one of the ways in which people try to optimize the back end is they create a data access layer. Has anyone developed a data access layer before? Okay. If you're an interface to a database, if you know anything about databases, you need to create some type of interface between the application and the database. And what they typically do is they cache. And that symbol there is Redis. Okay, it's an open source cache. What are some other caches out there today? Memcache? Any others? This was the last. That was the last meetup. It was CTO that spoke, which is a partner of ours at Heimdall Data as well. Remember that? Hazelcast is another type of cache, Greek cache as well. Any others? Gemfire, Pivotal Gemfire is another one. So you create a data access layer, and then you can cache SQL so that it offloads the database and it's quick. It allows response times to be faster. Now, what's the problem with that?
Invalidation.
Invalidation. And if I had that picture, I'd allow you guys to put it in the card. Very good. Invalidations is, from a computer science perspective, is one of the most difficult things to do. The second one, jokingly but also true, is naming variables. What this Netscape developer said. So now it's a very difficult problem. And I believe that Heimdall Data has solved it. So what Heimdall Data is it is a data access layer. In other words, it is a database proxy. The application sees Heimdall Data as the database, but what we're doing is we're not a database. We act as a SQL optimizer, a SQL solution that provides high availability and a lot of analytics, all the things that you need as a developer or as a DBA to manipulate and optimize your SQL. Okay? So here, people often say, well, how do you guys differ from Redis? They say that all the time. So when we say we're a database proxy and we cache, they say, well, how are you guys different from Hazelcast? Well, if you see here, down here on our banner, Amazon Elasticache, Hazelcast, Redis, Pivotal Gemfire, they're all partners of Heimdall Data. We don't sell cache. What we do is we help the developer intelligently cache into the cache. Does that make sense? So you choose the storage of choice, whatever it is. Heimdall Data will automatically cache and automatically invalidate the SQL results. Does that make sense? So we're not a cache. You guys choose the storage of choice, and we intelligently cache and invalidate. Okay? So that's one of the things we do. The second piece, which makes this very interesting for this solution, is that we're not a box on the wire. Okay? We're not sitting in between the application and database. We're actually distributing. So Heimdall Data is a data proxy that is an agent that resides on each application server. So there's no single point of failure. If one application server goes down, Heimdall Data goes down with it. But you typically have a load balancer in front of it, so you have the remaining application servers that are up and running. Does that make sense? Okay. So it's distributed such the fact that when the application thinks it's talking to the database, it does a read. We will send the results back very, very quickly in the application server view. Okay? So this network latency is removed. Because a lot of the queries that would have gone to the database doesn't even see anymore because it's being cached. So what the Heimdall Data proxy is, it is a conglomeration of a bunch of solutions, point solutions, such as F5 Networks, which is a load balancer. Have you heard of New Relic? Which is, what would you describe New Relic as?
Metrics and monitoring.
Metrics and monitoring. It's in the APM space, some would say, the application performance monitoring space. App Dynamics, which would be in a similar space as well. And then MariaDB. I put that in there because they have this database proxy also called MaxScale. It's an open source database proxy that does similar things to what we do, but it is primarily for MariaDB and MySQL. So what makes us unique is that we provide analytics, okay, SQL analytics, failover, we provide a lot of things that MariaDB MaxScale does. However, we do it for every single SQL database. We're database vendor neutral. So if you're supporting MySQL, Postgres, Oracle, SQL Server, as long as it's a SQL database, we're going to support it. So we're database vendor neutral. And you might ask, well, how do you do that? Because everything that I'm going to say in terms of these features and functionality, it doesn't require any code changes. So you install us in minutes, and there's no changes to your application, and there's no changes to your database. So the title of this meetup that says that it was something like auto caching integration in 5 minutes or something, it might sound like a marketing pitch, but it's really true. So we're not lying in that sense. It really takes minutes of integration to install a product and get it deployed. And this is the way that we do it. There's 2 packages that we have. And I'm going to start with your left, my right. Does anyone program in Java? No? Okay. If you have a JVM application, which is a JDBC driver. Okay. You have an application and you currently have a JDBC, vendor JDBC driver that interfaces to whatever database it is. It could be Oracle, it could be Postgres or MySQL. What you're doing here is you're shimming in our JDBC driver, our jar file, in between your current application and your vendor JDBC driver. And that's it. So all the change that needs to be made is you're changing the connect string, the URL. That's it. And you're ready to go. That's why we can say that you can install in 5 minutes. Okay? But what happens if your application isn't a JVM? And you write it in Python, Ruby, Scala, or whatever it may be. We have on the right-hand side another package called a Heimdall Database Proxy. And these proxies speak at the database protocol level. So we have a SQL Server proxy, we have a MySQL proxy, and we have a Postgres proxy, regardless of the programming language your application may be written in. Does that make sense? So if it's a PHP application, that doesn't matter. As long if it's a MySQL database, you would just use our MySQL database proxy. If you have a if you write in Java JVM, but you have a Postgres database, which one can you use? Either one. Exactly. You could use the JDBC driver or the Postgres proxy. These are the 2 packages we have, and this covers about 90% of the SQL databases. Any questions? Yes, sir.
That's operating as a single application. The proxy itself is operating as a single application separate from the Ruby on Rails app.
So the question is this data proxy running on its separate application? It runs as a separate process in the application server. It runs as an agent, okay, in the app server. So what we like to do is run distributed, such that you put our proxy or JDBC driver as close to the application as possible. But you could theoretically run that as a separate box in between the application and database as a centralized solution. If you want all optimal performance, you want to put it into every app server as a distributed. But either way, you can do it distributed or centralized. Does that answer your question? It runs as a separate process when you say it's a JVM?
Yeah. In the case of something like a Docker environment, where you have a large number of Docker containers running on one server, you could, if you wished, put one instance into the Docker container, or you could set it up such that the Docker host is running the proxy, and it supports all the Docker containers that are on that host, so that you still have minimal overhead, but you only have one proxy supporting potentially dozens of application instances.
It's very advantageous for Docker containers or microservice type of deployments. Because if you start proliferating a bunch of microservices, this is very, very nice. You have a centralized proxy in the app server for which all the services are talking to, or just drop in a JDBC driver per microservice, either way. So let's move over to use cases real quick to make sure we're on the same page, and Erik's going to show you a demonstration of these. The first one is the SQL results caching. Again, what we do is when you drop us in as a proxy, the first time it's going to go to the database, we see everything. We see all the requests, we see all the results, the SQL results coming back. And we are going to auto-cache and auto-invalidate all the SQL results. So literally, it's a click of a button. If you've developed a caching subsystem before with Hazelcast, with Redis, with Memcache, you can understand the amount of development resources it takes. We've done a survey, we've talked to Google, eBay, and Apple, and they've all said that on average, it takes about 20% of a developer's time over the year, 1 day a week, not only to create a caching subsystem, but to maintain it. Especially when data is very dynamic, you've got to tweak the cache TTL and the expiry, all that stuff, the invalidation. Well, all that's now being handled by our proxy. You don't need to fool around with that anymore, and we can guarantee data freshness. So that's our auto caching, and that's probably the most differentiating solution that our proxy has. The other one is automated failover. So we can do fast failover for MySQL, and if you have SQL Server, we also complement always on. So we just enhance it even more, and we have faster failover. Anyone use Postgres? Has anyone implemented PG Pool 2? So that is a failover solution. It is a good solution, but you have to develop. It's an open source, and you have to develop it, and it's work. It's work. So we're just a drop-in replacement for PG Pool 2, which is the Postgres open source failover solution. The third one is horizontal scale out. As your application grows, obviously you have higher data volumes, and you want to begin thinking about scaling out your data team. And so what Heimdall Data can do is make better use of read replicas. May I ask, what do you think I mean by that? Make better use of read replicas. Yes?
My guess would be within, for example, like Mongo, we've got read replicas that the application needs to be smart enough to connect to the right replica and respect hidden replicas and decide which is the correct replica to distribute the load to.
Yep.
But I know we're not talking about Mongo here, so I don't know specifically. That's what I'm hearing when I see horizontal scale out.
Very warm. So horizontal scale out, what you try to do first typically is you have a single instance of a database, you try to scale it vertically, throw more hardware in it. But then that has limitations, and eventually what you want to do is scale out, not vertically, but horizontally. So you're going to have a write server and a bunch of read slaves or read replicas. Okay? So, because the write server is expensive, and so in the sense that you want to make sure that the writes go to the write servers and the reads go to the read replicas. And so what we're doing here is that without any code changes, we're going to make sure that the writes go to the writes and the reads go to the reads. Okay. And Erik, do you want to talk about lag detection now, or talk about it?
I'll show that as part of the demo, where we can actually detect how long it takes for replication to occur from one server to the other, and we take that into account when determining where to send the query.
So part of this horizontal scale-out also includes, I can call it query routing. You may want to direct this query to a certain database server, whether it be write or read, or to another region, or keep it within region for data compliance issues. So there's a lot of flexibility by just writing a policy on the Heimdall Data policy and controlling your SQL. Lastly, we talked about
Sorry.
performance.
So,
Yes.
so back on that previous point, so are you scaling out the database instance, or are you scaling out instances of Heimdall, or is it both?
Well, it's both, but particularly if you want to scale out your database tier by adding more read replicas and adding more write servers, we can accommodate that without code changes, application code changes.
I'll directly show this in the demo.
Okay. I think I understand it now the way you're explaining. Thank you.
So we talked about performance, we talked about reliability, we talked about scale out, and then the last one I want to talk about is auditing for privacy compliance. So because we see all the queries going in and the results coming out, the analytics become very, very good in terms of what we can show where the bottlenecks are. And so we can log and we can show you who did what when for auditing, whether it be SOX, HIPAA. If you're doing any work for EU, there's a mandate in May, GDPR. Have you guys heard about that?
Yes.
So this helps in giving visibility and also filtering malicious data access as well. So that's sort of a security component that we can offer as well to help meet your compliance, which is looming. It's a minute. Is anyone working on GDPR compliance? What are you guys doing, if I may ask? It's coming, it's March. Okay. So let me dive a little deeper technically on how we do things before I ask Erik to come up. Let's talk about the caching and what makes this really unique. So I just hand-waved and said, 5 minutes of caching, we do automated caching, automated invalidation. But I'm going to go under the hood and tell you how we do it a little bit more. What we do is on every single app server, we are going to cache the hot objects in memory into the local cache. So it's this concept of L1, L2 cache. We cache the hot objects in memory, and the remaining we cache into the storage of your choice. That's the L2 cache. And it's here that the L2 cache of your choice, whatever it be, Hazelcast, Redis, or whatever, will communicate to all the other application server local caches to guarantee that the data is fresh, the local caches are fresh. This will be the arbiter or the communicator of the invalidation. Make sense? This is sort of like the messaging bus. We're using the pub sub of the L2 cache to communicate to all the local caches on the app server to ensure that the data is synchronized and is compromised. Okay? And all you need to do is just click a button and it just works. All right?
So you need one of those other vending products?
Yeah. It could be open source or it could be the enterprise version. Doesn't matter. But the great thing is you choose the server choice. And this only matters if you have more than one app server, right? To keep coherency. If you have one app server, it doesn't matter. We can just do it in memory.
Does that then mean I need one instance of my L2 cache globally? So if I've got a site in one part of the geographically distributed, I've got 2 sites. Does that mean I need one L2 cache that's shared amongst those 2 sites?
It's possible to do a geographically distributed cache. That becomes the domain of the cache itself. And basically, we leverage the messaging and cache coherence services that they provide in order to handle that layer 2 cache type piece. So we're not reinventing the wheel because caching itself is a hard problem to deal with. These products have been around a long time. We're leveraging them to do what they do great, and we're adding intelligence even more on top of them to make it very specifically caching of SQL result sets and keeping them safe to use.
Because, again, we don't want to reinvent the wheel. Elasticache, Hazelcast, and Redis, they're awesome caches. High performance, high scale, leverage them. What we're doing is providing intelligence, telling you what you should cache and what you should not. So you guys don't have to muck around with that. You guys should be, our motto is, you guys should be focused on revenue generating features.
So if I've got Redis on the West Coast and a Redis on the East Coast, they should be communicating amongst each other internally. The Redis product, we are relying on their coherency to make this work, right?
Yeah. Or, well, keep in mind that this is dealing with a database. Where is the database located in that?
One of those two regions.
Okay, so you can do the caching literally in the one place if you wanted, and that would be a Heimdall cache that's talking through the Redis cache, and then it can be talking to other Heimdall nodes in other locations as well, and using the Redis infrastructure as a messaging bus. So there's a lot of different ways you can deploy it for a geographically distributed setup.
Any other questions about caching? Is it making sense? Just intelligent caching? All right, so that's how we do caching, sort of an L1, L2 approach. And then I'm going to tie them all together now, and this is how we're deployed. It's pretty simple. There are two light blue components. For every app server, there's a Heimdall Data proxy. And in this picture here, in this slide here, there's 3 application servers. So there's 3 Heimdall Data proxies. It's all being managed and controlled by a Heimdall central console. The central console is what Erik's going to show you, that provides all the analytics, that's going to show you what to cache, what not to cache. How about, here's a situation, maybe that you don't trust Heimdall for doing the automatic caching, because hey, that's very sensitive data, and I'd rather be a little bit more, have a little more control of what to cache, what not to cache. That's fine. What we can do is, it's analogous to, the top 10 music hits. We provide the top 10 queries to cache. So we'll just provide recommendations. We just click the ones that you want. And Erik's going to show you that as well. So either way you want to do it, you could just set it and forget it, and we'll cache everything. Mathematically, that's the best way to go, and that's our recommendation. But if you're very picky, you can choose which cache recommendations to take. Some of them, or all of them, or none of them. So again, we are database vendor neutral. And we're cache, these are the partners that we are aligned with for strategic alliances. Any questions on this sort of architectural, high-level architectural diagram? Yes?
When you say failover, you're assuming that you've created the too-hot solution for the database and this isn't.
So what we'll do is we will health check the database, and the big assumption is that they're replicating. The replication is on you. That's a database issue. We're going to monitor on the front end the health of the database, and if one goes down, we're going to fail over to the other one that you designate.
I'll show that. Yep.
Anyone have their deployments in AWS? Okay, we have a wonderful wizard in AWS. We're a tech partner with AWS. We're an advanced tech partner. They really love us because we have a wizard that auto-detects your AWS components. So if you're an RDS, we detect it. If you're using Elasticache, we detect that. And if you're using CloudWatch, we detect that. And you just point to it on a wizard and say, oh, it's a drop-down menu, and then away you go. That's it. You start caching into Elasticache. Really simple. How are you, John? Okay. I think we're done.
Okay, let's get to the demo stuff. Showing it actually working. Okay, so let's first. Thank you, everybody. Again, my name is Erik Brandsberg, the CTO of Heimdall Data. And what I'm going to try to do is, as quickly as possible, show you a demo of some of the features being used. I have 2 environments. One is just on my laptop, and another is actually in the cloud. And you can actually go to it. We have a live demo website. And I'm just going to show you that and kind of walk you through that live demo website so you can see how this works. And if you want to play around with it later, after the meeting, you can do so. So the first thing that I'm going to start off with is I've got a couple of database clusters set up on my machine using Docker. The first one is a Postgres cluster, and the second one is a Galera cluster, basically MySQL Now, what I'm going to do is, if I can do this with just one hand, I'm going to go in, and this is an unconfigured instance of Heimdall, basically a raw, single, you can literally install this with a single command, which is also on our website as well. So I'm going to go to the wizard section, manual configuration. What I'm going to do is I'm simply going to answer all the questions on how to configure this. So I'm going to have to put down the microphone for a second. The configuration name, e.g. test. I'm going to select the database type of Postgres for my first example. Database host name, 172.17.0.2, which I happen to know to be the Docker instance IP. That could be a host name that would map to it if you have that all set up. Port 5432, username, Postgres, database password, guess what it is? Okay. Next, I'm going to enable load balancing. Now, I've only put in one IP address of one of my cluster members. I'm going to tell it to track cluster changes so it will become cluster aware. Our code will actually poll and figure out what your cluster configuration is, what nodes are what role, and it will take care of all that for you. Track replication lag, we'll keep track of the lag. Go in, we can select out what type of cache. Since I'm only going to be doing one instance here, I'll show a distributed instance in AWS in a few minutes. I'm just going to select local only. In effect, that's just the L1 cache layer being enabled, not the L2 cache layer. Next, I'm going to enable a proxy as managed by the management server, so everything's going to be on one system. Here, click through, and then it basically asks you what type of features you want enabled on this virtual database, on this instance. So you can simply say, okay, I want logging. I'm going to send all my logs to one place so I have one place to view it. Connection pooling. I'm going to set up some default cache rules, which are generally safe for most applications. I'm going to turn on read-write split. So I'm going to send reads to my read-only server if appropriate. An evaluate plan, that'll actually pull the execution plan out from the database on a query-by-query basis automatically for you, so that you have all that to view later in time. I'll show that in a minute as well. Review, it shows you all the settings that are going to come in. Click Next, Submit, and I'm done. Okay, I've just created a new proxy instance that will be listening on port 5432 on this server, and I can run everything through. And if I had everything set up right,
Postgres T.
yep, you can see I got some nice warnings telling me it was not done right. Let's actually look here, since we've got this opportunity. It only has one server configured. It couldn't log in to figure out what the cluster was. I'm going to commit that. I'm going to refresh that out. Test the connection. See, it's green. Let's look at load balancing again. And oh, look, there are two servers now. Why? It's a cluster. It figured out who the primary was, who the secondary replica was, and it's now set that to be a non-readable or non-writable server. It'll do read-write split. We're done. Okay? Even with an error, I think that was within 5 minutes. Okay, any questions about that? Okay, you'll notice that it gave you all nice alerts at the very top, alerting you to the fact that there's a problem. We've taken a lot of effort into trying to account for common problems that occur so that you're alerted right then and you can fix the problems. Okay, any questions on that? Okay, now I could do the same thing for the Galera cluster, but does anybody doubt that it would work the same way and it would find all three servers? Except in the case of the Galera cluster, it would know that they are potentially all writable servers. By default, however, because Galera does not allow clean writes to the same table on multiple servers at or near the same time, we default in a Galera scenario to making one designated write server and the others the read servers. But if that default write server goes down, it'll automatically promote another one and we'll start using it cleanly. Okay? We're trying to make the implementation of a lot of these technologies as easy as possible. Any questions on the failover? Let's actually do a failover then and show how quick the failover can actually occur. So we've got this nice button here on the VDB tab to test VDB. Now, if we go to our dashboard, if everything is set up right, we will see that it will start generating some traffic. This is basically, we create a separate database and table instance. We're just reading and writing into it. Very simple type setup, just to verify, are things working the way that you expect them to work? I'm gonna go over here, and I've got a script that will trigger a failover, and it's killing the master instance. Okay? Now, it'll do that just because it's giving some errors, but what we can see here on the dashboard, the monitor response time is a good place to show it. You had two servers here, the primary and replica. When that primary failed, it took over within 2 seconds, promoted the other server, and we're now online with it being both the read and the write server. 2 seconds. And we set it all up in less than 5 minutes. Okay? Any questions? Okay? This supports the cluster awareness, supports SQL Server, many variants of Postgres, many variants of MySQL, including MariaDB, Galera, traditional MySQL replication. With SQL Server, it includes always on as well as mirroring. Okay, so let's leave our local environment, and now we're going to move on to the live demo environment that you can see online as well. What we have here is a configuration that contains 3 different applications. One is Magento, one is Odoo, and one is a SQL Server application called VivoCard. Odoo is using Postgres, and Magento is using MySQL. So let's start with Odoo. And what I'm going to do is I'm going to simply click a couple of different pages. You can come over here onto the dashboard, click our Odoo, and it shows you the statistics for that particular instance. Now I can pause this. Let's take a look at this. The database queries were taking about 2.4 milliseconds to pull. And if we actually take the database out, you can see that the average response time came down to about half a millisecond. And if we exclude that, you can see that the cache hits out of the local cache were approaching 100 microseconds. So you can see the difference of performance between these different levels, depending on where they came from. And for reference, this is a Postgres, these instances are in AWS, running off of RDS. So they're what you would expect to see actually in a real world environment. Okay, we can unpause that. And if we wanted to, we can do the same thing for these other databases. But one of the key things is that for all of these applications, when you start putting any sort of real load on them, they get to about a 90% cache hit rate. Okay? It's really good. E-commerce is actually a really nice sweet spot for us, but a lot of applications see 75% or higher. Okay, so that's the live environment, this environment. I'm going to show you the wizard to show you how the AWS integration ties in. Since it sounds like a number of you are using AWS, it automatically knows that you're in AWS. It detects that and gives you an option for AWS Detect. If you have the appropriate AIM role attached to the Heimdall instance, it will pull your RDS configuration and any Elasticache configuration you have. It'll give you your clusters that are available on it. Let me use a SQL Server one. And if you have Elasticache set up, it'll give you your clusters there. You simply click that. If you want detailed cache metrics automatically pushed into CloudWatch for you, you can simply push that and it'll actually give you an instance by instance cache metrics into your CloudWatch. So lots of good integration with AWS that you just don't even have to worry about. Now we go in, and since we already have a SQL Server demo set up, I'm going to make a unique name. I'm going to type in password here. Next. Okay. I could do load balancing at the moment. This isn't a multi-node cluster or anything, so that's not going to give us anything. It's populated the Elasticache settings for you, so you don't have to look them up. There's no risk of back fingering it. You just click on next. We've already got something on 443, so I'm going to put in 444. You can set how the proxy binds to restrict traffic for security policies as well. Next, again, you can select everything out. Because I did not do load balancing, it did not give me the option of rewrite split. So it's trying to give you sane choices so that you don't have to worry about things that just won't apply to them. Review. Next. Submit. And we're done. Okay? You can go into the proxy configuration, you can see all the various settings that are set for it. You can go in, you can change those as well. Here are your cache settings, the data source, everything else. So just by going through the wizard, it pretty much takes all the work out of making the decisions for you, and there you are. Any questions on the setup? Yes?
PCI input cache, is that where it starts like additional logging?
Okay, good question here. The way that it works normally is that we push the cache objects into the layer 2 in order to provide it for cold start type functionality, but we also have a copy in the layer 1 locally. Because a lot of these protocols aren't necessarily encrypted, you don't necessarily want to push sensitive data over a non-encrypted connection, but we can still use it to invalidate tables.
Oh.
So it'll keep a local copy, but won't push it over the unencrypted protocol, which could be considered a vulnerability.
So you lose some performance, but you gain the engine not being misfired.
Correct. Okay. So there's that option. Auto-tuning will add some additional intelligence to try to figure out what it doesn't make sense to do caching. When doing testing, you generally want it to work in a very consistent way. But when you're in production, you actually want performance. Okay. With the auto-tune turned off, it is more aggressive in trying to cache, even when it may not actually give you a benefit. That way you can spot issues before it goes into production. Okay?
So leaving it unchecked is
It basically, depending on the scenario, it may or may not be a big difference. But the idea is that it may give you a little bit more, and it kind of auto-learns on the fly. So if something comes up where you want to do caching because the DOS attack needs to be mitigated, it'll learn to start caching something that just keeps getting asked for. Okay? Now let's go into the rules just to give you an idea of how these are set up. This is, let me show you, say, Udo. This is the entire rule set to give logging, caching, and automatic plan extraction out of the system. If we go to Magento, there's one more rule. This is the reader eligible rule, and that allows you to do the rewrite split. And you're basically saying anything that starts with a select that our internal code has not also detected to possibly be a write or be part of a transaction, it's eligible to go to the reader. But for example, if you do a select for update query, we detect that as being technically an update and we won't send it to the reader. We know that that's something that's part of the transaction and it should not be sent to the read-only server. Okay, there's a lot of little logic points in there just to try to make it work right out of the box the first time. Okay, so once we have everything in place, let's actually look at the analytics. I'm going to do this for Magento. I'm going to pull that and click the Analyze button. And we now have this nice view that tells you what queries are being cached. The number here represents which rule number attached to the VDB is actually triggering the caching. You can see by hovering over any other rules that also match that aren't cache rules. So it tells you exactly what rules are actually applying to this query, so you know what to look for if something's not working right. In fact, if I click that cache button, it'll highlight for you which one was causing the cache. If you cut that in yellow. Okay, you also see the DB usage, and this 17% says that 17% of the time the application is waiting on this query. Okay, so that is one that you should be looking for. Now, the cache hit rate is only 1.5% here. Now, that's probably just because it's not doing a whole lot, but also I haven't pumped through a lot of traffic that would actually give a nice cache hit rate. But in any case, this tells you that this is showing up a lot of the time spent on the server. This little green icon here, this is where that evaluate plan option came into play. If we hover over here, oh look, we can click that, and we've actually got our execution plans pulled out for us. And by default, when you have an evaluate plan rule, it will, for a given query pattern, pull out one execution plan for that pattern per hour. So it's not like by having that enabled, you're slowing things down a lot, but it gives you a nice sampling of execution plans over time so that you can look at these and go, okay, I see where there's a problem now. Okay? This view we're aiming for to be this is what you give to your programmer that either has developed SQL or possibly the DBA, or the two of them to work together. This is where the problem is. Helping. Okay, we're trying to make it basically one view, and we'll be adding more to this later. Any questions on all this? Okay, I'm going to show you one more feature. Now with Odoo, this is Postgres. We do have a Postgres specific feature here. We see that all the query or all the statistics from the perspective of the application. But we've also got this nice little option of DB side statistics. If you're familiar with the PG stat statements tool, this actually will allow you to pull that data on a minute-by-minute basis. We aggregate that for you and provide this nice view of what it was that was seen on the database side. And you can now look at, for example, the average response time for particular statements. Now you can see that almost all these, the database is saying, this is nothing. It takes no time for me to give that back. But if you actually go onto the application side, it's a very different story. And showing these two perspectives can make a huge difference in understanding, aha, it's not the database that's slow, it's the interaction between the database and the app. Okay. Were there any particular topics that Roland had gone over that I have not touched in the demo that you guys would like to see?
I didn't understand the whole rule 2, rule 3, like what was that about?
If I click this rule 3, you'll see that it's highlighting rule 3, and that is one of the ones that was matching in that particular one. Okay, sorry, let me go back to analytics. The rule 3 means that it's not caching, but this was the last matching rule. If it's a caching rule, it'll show directly, so that's caching too. We're still kind of tweaking how to do the visibility, but I really think it's important to understand what rules are matching against particular query patterns. We may adjust the how that is presented in a relatively a new build relatively soon. Okay.
Can you go back
Yes.
to the previous slide? We have the show supervisor. Go back, just go back.
Which, what were you trying to
Yeah,
show?
there's a show is supervisor. I think they're really on point.
Sorry.
Show is supervisor.
Oh,
Hold on. Show is supervisor. Down.
Oh.
Super user, sorry. Show is super. Look how long it's taking. Why isn't that cached?
okay. This is not a select. Okay. By default, because the shows could be doing shows with data that are dynamic. We're not doing that by or we're not doing that. But you can create a cache rule manually that will trigger that. And because it's more specific than our general rule, it'll allow that to be cached. Okay? Any other questions or any other topics that I may not have shown? I know that time is...
Stored procedures would be similar.
Actually, let me pull up the this SQL Server demo, analytics, and then we can filter on all they would show up. I guess I don't have any that are in the logs at the moment, but stored procedures like for SQL Server will show up as calls, and you can trigger those to be cached as well, but by default we would not be caching those. We do have the ability to tag the interactions between stored procedures by tagging what tables they're associated with. So if a stored procedure is writing to a particular table, then you can tag that so that when it writes to that table, it invalidates other stored procedures that are reading from that table. Okay, so even when we cannot parse the SQL, we can still ensure that proper caching is done.
So I don't know if I just missed this, but did we show the auto invalidation, cache invalidation? So we can do an update here.
That's harder to do a demo on, but basically whenever we see a write against the table, we know that, and we basically keep the last modified time for each table, such that when a read against that table comes in, if we pull from the cache an object that's older than the last write, we know it was invalidated. Then we throw that out, and then pull from the database and repopulate it to the cache.
How are you generating the cache keys?
We do not generate the cache. We simply follow what queries are made against the database, and we cache those. There's no point caching data that nobody's ever going to access. Okay? And most of the benefits that we get actually are for objects that are cached within the last 5 minutes.
So auto invalidate logic is on a table basis, not
It is
a row basis.
It is currently on the table basis because there's no easy. It's an extremely difficult problem without actually being the database engine to figure out what rows were actually touched.
I actually have a question. So how transparent is your JDBC driver? And as you know, JDBC vendor-specific JDBC drivers have their own APIs that sit outside of JDBC spec. For instance, like Oracle has like graph cursors.
We're following the JDBC spec, which most applications we've seen do follow. It's usually very custom applications that are using the non-standard API calls.
Yeah.
In many cases, because of what we have embedded in the functionality, the reasons why you would want to use some of these API calls actually goes away. Okay, for example, you could do some client-side caching with the Oracle thick driver, but we're doing that for you, so you don't need to worry about their APIs.
Right, but there are some things like ref cursors. I don't know if you're okay. So what's the problem with that? So if you're not reading all the entire result set all at once, and that's cached, so you only read 3 rows out of 10,000. And next time you see, you want all 10,000. So it's obviously not the.
We actually do cache based on the number of rows that were requested. There is a JDBC API call for that. That would allow us to know how many rows, and we're actually somewhat familiar, or we ensure that in the worst case, we go to the database and pull it for you.
You do.
If we need to.
So how do you know that partial read was?
If you're using an API that is not part of the JDBC spec because we're acting as a shim, we're going to say this method doesn't exist. Okay, so you're not going to have that problem because it's going to throw it out before you even have the problem.
Right. So actually the ref cursor thing would just be completely thrown out.
Yeah.
So not even be cached.
Yeah. Okay, we try to be as safe as possible.
Yeah,
and then
I'm just nitpicking. The nitpicking
Yeah.
just kind of like sits outside of your.
Yeah.
Case.
Oracle and their JDBC drivers are of particular difficulty when you go outside of the JDBC spec. I will admit that. Okay.
Understand.
Any other questions? Any other comments? Anybody need to put their cards in for the drawing?
Question. What if you have tables where you know that you're going to be keeping some of it, like yesterday, all the older data is going to be the same as today's data? So you can cache the old stuff, not the new stuff.
You can be very specific on the rules. You can match a regular expression that looks for various parameters, and we're quite flexible, and things like that can generally be taken care of. We also have the ability to override our invalidation logic. For example, if you know that a table is write only, and you'll never read from something unless it's been written. Basically, writing will not invalidate something. In a case like that, you can say, well, writes to that table will not invalidate it. Always allow the cache to remain in memory.
Right, it's right.
Correct.
So you're saying
The rights would, in a case like that, there is no invalidation. Okay? You're always appending to the end, and you're only reading stuff that already exists. If you can say that, then whatever you've read, you can always keep in cache. Period. Okay, so there's a lot of little controls like that that are built in as part of the rules. And then, for example, within our documentation, you go to configuration rules, and we're going to be adding in a lot more information on this. But the actions that are available are there. And then as well, for example, if I go to rules, if I add a rule, it gives you a list. Let's say I want to do a cache rule. I can open this up. Okay, I can add another one. It gives me all available options. I want to click on Evict Tables, and it gives you tooltip hints to show you what that option actually means. They're trying to make it as self-documenting as possible. Okay? That's not what you normally get in open source software. Okay?
Eric, you want to show that how simple it is to download, like a simple question?
Okay? Bam, right there. That'll install onto a Linux system. You also have a Docker file that you can use. We're in the AWS Marketplace in Azure. Now, if you did download, let's say tonight, you're going to see a slightly different view because we're updating our UI and demonstrating the newest user interface. It'll work almost exactly the same way. It's all user interface updates. But if you go into the software, there's an option in the updates to download test versions of software once you're in. That will pull the newest version. It's just not released yet.
This is not how to do
No.
it. Okay.
Okay? Any other questions? Okay. Eric?
Thank you, Erik Brandsberg and Roland Lee. We're now going to give away this JBL Flip 4. Can I ask you to reach in and mix things up? Mix it up a lot. Okay. Put your guns up. Roland, can I ask you to step up here and pull the card out?
Someone named Gray Hill.
Congratulations. Thank you. Thank you all for coming. Our speakers are here for one-on-one questions. Feel free to come up now and ask them.
Thanks for coming, guys.
Yes, thank you very much.
Thank you.
You've been a great group.